Thanks, everyone, and good morning. I'm really excited to be here. This is my first time at the symposium, and I walked in the room. I remarked that I was very excited to see the size of the room and now the number of people here. I wanted to talk a little bit about who we are, but mostly by way of this year, 2011, and sort of just how extraordinary it was. So I'm going to talk first about, oh no, I think I pushed the wrong button, Dave. There we go. Okay, thank you. I'm going to talk really quickly about who we are here at the beginning, and then I'm going to spend most of my time talking about 2011. I'll start out, how much water do we have? What was the total volume? How well did we forecast that? And then I'll get into sort of the verification of our daily forecast. How high did it get? What were the peak flows? And I'm going to try not to overwhelm you with a lot of charts and statistics, although I think it's really exciting, so please bear with me. And at the end, I'm going to talk a little bit about the 30-year average update that we're going through right now. So the Colorado Basin River Forecast Center, this is where I work. We're located in Salt Lake City, but we forecast for the entire Colorado Basin plus the eastern Great Basin where Utah is. So we make forecasts for stream flow on a whole bunch of different time scales, from the seasonal all the way down to the hourly. In Arizona, we get involved in situations that are sort of near to flash floods. And we're situated inside the National Weather Service, so we work very closely with the weather forecast offices in our area on what they need to do in terms of flood warnings, flash flood products, that kind of thing. So with sort of, I keep pushing that button, with sort of that as an introduction, I wanted to sort of take you back to fall of 2010. This is the beginning of the water year. This is sort of what we were looking at. We were coming off sort of a decade of drought in the Colorado Basin. Of the last 10 years, we only had 2 that were above average, 2005 and 2008, and a couple more that were near average, but a lot of below average years. And so we were looking at last October, Lake Mead was seeing the lowest level it saw since it was filled in the 1930s. So there's a couple newspaper stories here that describe that. I'm sure a lot of you read other newspaper stories. And so we were getting a lot of requests for information from stakeholders about, well, what are the chances of a shortage in the system? There's never been a shortage on the Colorado system, and we were sort of staring that down. If we had another dry year, the chances were pretty good for seeing the first ever shortage. So that was kind of the pretext going into the season. And then we had December. This is the pre-holiday storm that came through basically the week before Christmas. It dropped up to 8 times the monthly normal precip in the course of that 1 week. You can sort of see the storm track on here. This is the precipitation analysis that we do, is a percentage of average for the month of December, and you can see that all these purples are areas that were sort of in that 4 to 8 times normal for the month. So Southern California up through Southern Nevada into the Virgin River Basin. Lake Mead went up about 2 feet just from this one storm alone. And you can see there was also a lot of snow deposited way up high in the mountains. So that sort of kicked off our forecast season, and we put out this forecast. This was our January 1 forecast for inflow to Lake Powell. We were forecasting at that time 9.5 million acre feet, or about 125% of normal. And so you can see this chart. I'm going to show a few of these. The red dot is the forecast. The blue is the average. So you can see the red dot was higher than the average. And then when we presented this forecast, we have webinars every month where we sort of lay out what the forecast thinking is, as well as the forecast itself. And I think it might have been Dave Kanzer. Somebody asked me when I presented this forecast, is this just irrational exuberance, or do you have some data to support that forecast? Because people were so used to seeing below normal forecasts or below average years that they didn't. There was a lot of skepticism early in the season that we were actually going to see a year that looked like this. So let's fast forward into April. You can see this is the time series of the forecast from January through April. Pretty much not a lot of change. We sort of kept the sort of average winter season going between January and April. And on April 1st, our forecast was still for 9.5 million acre feet into Lake Powell, 120% of normal. And there were some changes during that period that became important later. I'm showing on the top here is the Green River Basin, and on the bottom is the San Juan River Basin. And you can kind of ignore most of the chart, but the point is that in the San Juan and sort of basins to the south, there's this sort of this downward trend. We weren't getting enough snow in those basins to even stay at average. So the forecast for the San Juan Basin was now sort of looking at around 90% of average, whereas in the Green Basin and sort of areas to the north, we were seeing a lot of snow, and the forecasts were sort of gradually growing, and we were up to, I think it says 125%, 129% of normal, something like that. And then we had our spring, April, May, and June. And this was a really extraordinary 3 months. For the Salt Lake Airport, it was the wettest 3 months on record of any consecutive 3 months in the 120 years of record at that point. And so this chart is showing just the precipitation. I think one is for the water year to date and one is for the 3 months. The point is there's lots of blues, which are indicating areas that are sort of 1 to 200 to 300% of average. The temperatures, it stayed very cold. I'm looking at Salt Lake City just because I had the data for this. The red line is showing the average temperatures, the average daily temperatures for the months of April, May, June, and July. The black is what we saw in 2011. And you can see that almost every day was below average, in a lot of cases well below average. When we did get to near or above average, it only lasted for a few days at a time, and then we would cool off again. So the exception to that is when we got into sort of late June, early July. That's when we had our first real significant prolonged warm period of time. And that is, you all know, we all lived through this, that's really late in the year to sort of see that first warm period of time. This chart below is just showing some statistics for the number of days below average during this time period. 2011, there were 92 days. That was the highest on record for this particular station. If we did this same analysis for western Colorado, we'd see similar results. And then the last sort of piece of information that's important for looking at streamflow predictions is the snow. And this was really extraordinary to watch this year. This is a chart showing the SNOTEL sites at the end of May, which in a lot of years, most of these sites are melted out by then. But this year we had a lot of snow left. All the black squares on this chart are showing you where there's a daily record for that day, for the end of May, the highest ever reported snow water equivalent value for that station. And that statistic, by the time we got to late May, more than half of our SNOTEL sites were showing a daily record. So we were looking at a very, very large snowpack very late in the year, which could potentially be very dangerous. And so we were putting out forecasts for very high stream flow, sounding the warnings and watches for flooding, but a lot of that didn't materialize because of the temperatures and the cool period that we saw. So before I jump to that, let me just say one more thing about how much. This is what happened for Lake Powell inflow. I remember I was saying we were forecasting 9.5 million acre feet in April and January. We ended up getting 12.9 million acre feet. So the answer, I think, Dave, was no, that was not irrational exuberance. If anything, we were underestimating. And you can see once we got into that really wet period of April, May, and June, the forecast went up. Here's April 1, here's May 1. The forecast went from 9.5 to somewhere closer to 12, and then by the time we got to June 1, we were forecasting pretty close to what actually happened. So we ended up with 163% of normal for Lake Powell inflow this year, lots and lots of snow. And that's the kind of how much. And I wanted to transition to talk about sort of how high, how extreme was the flooding at this point. We all, again, lived through this, but here's a couple of newspaper stories to just kind of remember. We had flooding or near flooding in a lot of places in western Colorado. On the left is Steamboat Springs. On the right is here in the, I think, Mesa County. I think that picture's in Mesa County. And so this is kind of what happened. The wettest areas were in northern Colorado, and then as you move further south, it wasn't near as wet. By the time you got to the San Juan Basin, things were pretty near normal this year. So these charts are showing, these are from the USGS, and they're showing the stream flow for the last 2 years. The top chart is showing you the Yampa River, which is kind of the epicenter for these high flows. So the coloring is showing you sort of the historical context, and then I'm showing 2 years of data on here, so 2010 and then 2011. And then I can't even read my own graphs, but I think this one is meant to represent the upper Colorado main stem. This is somewhere, Glenwood Springs maybe. I can't read that. .0, thank you. And then this one is somewhere in the Gunnison. Grand Junction, thank you. So the point is that there's a lot of water here, still a lot of water in the sort of upper Colorado main stem. Gunnison, not quite as much. But what's really remarkable about these charts is the sort of length of time that we saw high flows. You don't see these black spikes, the black lines really spike too high above the historical context, but you do see them stay high for a really long period of time. And that has to do a lot with the temperatures we saw in the month of June. We had a really cool June, which kept the stream flows from getting really high for a shorter period of time. So let me talk quickly about the forecast that we make for these. We make two different kinds of forecasts for peak flows. The first are the long lead forecasts that we start making in March. And these are, we give a range of flows. They're updated typically once a month. This year we did weekly. And they're meant to sort of give an early indication of the sort of likelihood for high flows or flooding. The other kind of forecast that we do year-round are our daily forecasts. Every day we're issuing forecasts that go out 14 days that include temperature and precipitation forecasts. And we're forecasting the entire hydrograph, the time series hydrograph for that period of time. And we do this for a lot of points. So let me just show you the kind of density of these prediction networks. On the left is the long lead forecast. So you can see there's about 60 of those that cover the upper basin plus the Great Basin. On the right are the daily forecasts. There's about 450 of these that extend down in the lower basin as well. And these are just snapshots from a couple different days this year, showing in the case of the red dots where we had either flooding occurring or flooding forecast to occur. So let me just show a few examples of these. I promise not to show too many charts, but I can't resist. This is the Yampa. I'm looking at the Elk River here, which is a tributary. It comes in just below Steamboat Springs. The black line is what actually happened. The red line is the first 5 days of the forecast that we make every day. So the extent to which the red lines are different than the black lines tells you something about our forecasts are not perfect. We don't claim that they are, but we would like to think that there's some skill, and I think you can see that skill by looking at this chart. So what happened here is we had the Elk River peaked in early June, and then it came back down as we cooled off, and then sort of went back up and down as we got warm and cooling spells throughout the month of June. And then it started to run out of snow when we got into July. And you can see that we did fairly well at that point. We got a little bit higher in here in the middle part of June than we would otherwise. There's an interesting story with this particular forecast point. Aldous Stratton, who's the service hydrologist here in Grand Junction, he would run some calls weekly with emergency managers. And after this first peak, but before the second peak, we had a question from one of the emergency managers in Steamboat Springs, and he was basically asking, I wonder if this person's here, he probably is. He was basically asking, well, you know, once the Elk River peaks, then the Yampa is going to peak, and the elk won't come back up again. And so do you really believe, you can see the red lines here, we're showing the forecast coming back up. We're showing that the Elk River is going to come back up to sort of near levels where it peaked in early June. And he was basically questioning that. He's saying, well, you know, the elk's already peaked, I can see the Yampa coming up, and according to sort of watching what's happened on the rivers in the past, he doesn't expect that to happen this year. And we sort of pushed back and said, well, we still see a lot of snow in the SNOTEL sites. We're looking at the data sets from the satellites, and we're seeing snow on the ground up there, and we do think it's going to come back up. And in fact, it did come back up. So there is some skill in this forecast system that maybe can sort of dispel some of the urban folklore that's out there in years like this. The long lead forecast that I mentioned, this is for that same point. You can see back in March 1, this is the first forecast that we issued. The time is on the x-axis, flow is on the y-axis. The shading, the gray shading is showing you historical ranges. The red line is flood stage. The blue line is what happened this year, what ultimately ended up happening. So you can see our March 1, our April 1, our mid-April forecast, they were too low because we hadn't seen the snow coming that was going to materialize in the months of April, May, and June. By the time we got into late April, that snow was largely on the ground, and these forecasts worked out pretty well from that point on. So, you know, this is one of the higher cases where the observed was you can see a record value. It's above the historical range, but the forecast system, I think, did pretty well here. Let me move down to the upper Colorado. Here I'm going to look at .0, just as a sort of proxy for that area. Again, we saw long periods of prolonged high flows. In a lot of cases, they were above flood stage. This one was forecast fairly well. You don't see a lot of difference between the red and the black. Not quite as extreme as what happened up north in the Yampa and the white, but still a lot of snow in this area. Here's the long lead forecast for that point. You can see the same kind of pattern. The observed streamflow here, sort of as you'd expect, wasn't quite as high as we saw further north. And the forecast had the same general characteristic where we started too low, and in this case, we ended maybe a bit too high. And then finally, I wanted to talk about the Gunnison just quickly. This is looking at the East River, which is a tributary for the Gunnison way up high near Almont. This is the black line is again the observed stream flow, and you can see this one was forecast fairly well. Once we got into July, in the Gunnison, we saw some monsoon moisture, precipitation that was not particularly well forecast, liquid rain that fell, and we didn't really have that included in our model. So you can see we kept trying to take the stream flow lower than what actually happened. And that was true in the Gunnison and the San Juan and those kind of places. Not that moisture didn't really make it further north to the levels that we saw in the Gunnison Basin. And then here's the peak flow forecast for the East River at Almont. Same general pattern. Here you can see that this is the mean daily flow. I think it actually did flood it instantaneously, but the mean daily flow did not flood there. And the forecast ended up being a little bit too high for that point. So sort of in summary, this should say 2011, oops. 2011 was a really, really interesting year. We had the most inflow to Lake Powell that we've seen in about 20 years, in 1 year. You know, we're going to be doing more verification. What I showed you is sort of the tip of the iceberg. I didn't want to overwhelm you with a lot of charts and plots. But I think what we've seen is that our forecast system has real skill. We have some issues certainly that we need to work on. Snow-covered area is one of those. We need to work on ways to better interface with the new science that's going on with remote sense data and things like that. Dust on snow is obviously another one. But you know, for the most part, our forecast this year panned out fairly well. The volume forecast panned out very well, as you saw with the Lake Powell example. The daily forecast and the peak flow forecast, those are so dependent upon what actually happens with the sequencing of temperature and precipitation that those didn't pan out quite as well as the volume, but I think we still did fairly well. I wanted to put in a plug right here for a couple things we're doing. November 4th, we're going to do our annual stakeholder forum in Denver. Last year we did it in our office in Salt Lake, but I wanted to sort of take it on the road and out to hopefully get some new people. We'll be doing two webinars this fall, one in October and one in November, going into more detail with this verification. And we love to get out in the field and sort of meet with individual stakeholders that are using our stuff. So if you're interested in doing that, we'd love to do that with you. The last thing I'm going to talk about real quick is this 30-year average update. Every 10 years we roll forward our average. So right now we're using the 1971 through 2000 period, both for historical data that we use to make forecasts as well as determine our averages. And we're rolling that forward right now. So this next year we're going to be using the 1981 through 2010. So I wanted to show, I've showed these slides a few times, some of you have probably seen them. I wanted to just show how those two averages compare to each other and what that means for our forecast that you can expect to see this next year. I'm going to start up with the Green River Basin. This is where we saw the biggest difference. So this is just a time series of inflow data to Flaming Gorge going back to, I think, the 1940s. The red line is showing you the 71 through 2000 average. The blue line is the 81 through 2010 average. And you can see there's an 18% difference between those two. That's extraordinary. That's a very large difference between a 30-year average. And I'll show the other kind of major basins of the Colorado next, and none of them are this large. So the area we're expecting to see the biggest impacts from this change are going to be in the Green River Basin, especially north of Flaming Gorge. Colorado at Cameo, this is the Colorado system above the confluence with the Gunnison. The difference here is only 4%. You can see the two lines there. Here's looking in the Gunnison Basin, Blue Mesa inflow. Here the difference is 6%. And this is Navajo down in the San Juan Basin. There the difference is also 6%. And then if we aggregate that all to Lake Powell, the difference between the two 30-year averages is 11%, which is still, that's a really big number. So if you're interested in the basin as a whole, a lot of this is obviously driven by the green But this is going to have some impacts, especially on early season forecasts. These green lines I just added to the chart, these are showing you all the 30-year averages we have for the data set for Lake Powell. This goes back to 1904, I believe. So the first 30-year average is 1911 through 1940. And if we just look at just those 30-year averages, those are what's plotted here. And it's interesting to note that the 1981 through 2010 average is the lowest out of those. I think there's 8 on there, 9 on there, something like that. So what does that mean for the forecast? I'm not going to read all these bullets, but essentially what it means is our early season forecasts are driven by climatology more so than the later season forecasts. Once we get into sort of April, May, June, the forecasts are really determined by the snow on the ground at that point. Early in the season, we're also looking at the snow on the ground, but there's a lot more snow accumulation season to come when we're on January 1 than when we're on April 1. So the difference in climatology is going to impact those early season forecasts more. So the forecasts that you're going to be seeing in the next few months are going to be influenced by this difference. And everything else being equal, they will be lower. They're going to be lower just because that climatology period is going to be lower. So if you look at the forecast as a percentage of their normal, that value should actually be about the same as what we've been seeing in the past, because you're essentially taking a forecast that's a little bit lower and dividing by a normal that's a little bit lower. So if you look at a percent of normal, like the 125% inflow to Lake Powell, that number should be about the same. Anyway, this is just something to be aware of, especially if you're using these forecasts in any kind of detail, that there will be a change this year, and that's kind of it. So with that, I will stop, and I think there's time for a question or two, perhaps. So does anybody have questions about 2011? So right, the question is, why do we not use a rolling average instead of the 10-year update that I described? The 30-year average that updates every 10 years is a WMO, World Meteorological Organization standard. So that's why we've used it in the past. Going forward from here on out, we are looking at, we're probably going to keep in our forecast system the data from 1981 forward. And so when we get to 2020, we'll have 40 years of record. And the reason for that is the SNOTEL network, which is really important for our forecast. That came online in the early 80s. So there's a sort of a disconnect between the data set in the 1970s and before and the data set in the 1980s and after. We don't have near as much information, especially in the mid-months in the 1980s and after. We had snow course before, but snow course data you only get once a month. SNOTEL data you get every day. So we're really looking forward to this new 30-year average. We think the data set itself will be richer and sort of will be better than what we had with the 71 through 2000. So I don't know if that addresses your question, but kind of maybe.
I'm just wondering why you don't use a rolling average and adjust it every year.
Right. I mean, we've experimented with that, but these forecasts are coordinated with NRCS, and they're used by the Bureau of Reclamation and others. And if we look westwide, they're used by a lot of different other stakeholders. So moving sort of from the paradigm where you update every 10 years to a paradigm where you update every year, there's a lot of institutional barriers to that. And it's not really clear from the science where you're going to gain a whole lot by doing that. So there's a lot of sort of inertia, and it's an arm-waving answer. But anybody questions about 2011? Anybody awake out there? There's a question. We're going to have one stakeholder meeting on Denver on November 4th, I think. November 4th. And there's information on our website about that. And if you want more today, come talk to me. I can tell you about it. Essentially what we do with the stakeholder forums is it's an opportunity for us to hear from you, as well as for us to go into more detail than I did here about what we're working on and what's new. We have some development capacity in our office, and we want to sort of tailor where we're going to what really matters for stakeholders. So this is really important for us to sort of hear what are the big things that stakeholders want from us.
Wouldn't it make a little bit of sense to have the meetings within the basin?
That's a good point. We had our first one, like I said, in our office in Salt Lake City, which is also outside the basin, but we covered the Great Basin as well. So the thinking is that we have a lot of stakeholders in Denver, in the Denver area in Colorado, and it's easy to do a meeting there. It's easy for people to get there from around the basin, easier than probably here in Grand Junction, for example. But if it works out there, this is an experiment, we're certainly open to doing it in other places in the future. Any other questions? Nobody's asking about 2011 yet. I guess everybody's just, yes.
About the National Weather Service forecast, do you ever try and tie those in? They do these forecasts for, I guess it's they that do them for like, you see them on TV for like maybe 6 months or maybe even further out. And how do they tie into what you forecast? I mean, was there a good correlation for 2011? Did the Weather Service pick this up or no?
I should be clear. We are the Weather Service, so those forecasts you're seeing are our forecasts. We coordinate with the NRCS also makes forecasts. Those are the two major forecast agencies for the Colorado Basin. And so, yes, they are coordinated. They correlate fairly well. There are differences that are more subtle than large. But yeah, the forecasts that you see referred to as Weather Service forecasts are our forecasts. Great question. The forecast is for the balance of this year and going into 2012. We're looking at probably another La Nina year, or at least equal chances for La Nina in a neutral year. And I say that sort of hesitantly because La Nina, El Nino doesn't typically have a very strong correlation with what happens in the Colorado Basin. But La Nina, El Nino is really where most of the predictability in the climate system, sort of before there's any snow on the ground, that's where a lot of the predictability comes from. So scientifically, there's not, I think, a very strong basis to stand on to make a lot of predictions that make a lot of sense for next year. For the rest of this year, we're still looking at high base flows. I was telling somebody before the meeting started, the Wind River Range and the Green River, they still haven't melted all their snow up there. So we're still seeing higher than normal flows from that, and we're going to see that through, probably the next month and a half or so until we get snow on the ground. So we're situated, our antecedent conditions going into this next year are very good. We're going to have very wet soils, because of this big year we just had. So we'll be positioning ourselves well, even if we get sort of an average snowpack, to have an efficient runoff next season. But in terms of how much snow we're going to get next season, that's a really tough question to answer, especially for this basin.